Discontinuity here, and we're in the second part of section 1, and our target for this video is we want to investigate a limit using a graph. Now, graphs of functions can be very helpful for us in investigating limits. So what we'll do is we'll take a peek at this example right here. If we look at this graph right here, it's a piecewise function. We want to determine each limit based on this graph. Notice the first one, limit as x approaches 0 from the left. If I let x approach 0 from the left side of 0, if I click and drag this point here, I'm going to approach 0 from the left. The function value is going to show up right here. If I approach 0 from the left, you can see that the function value approaches 0, and also on the graph, you can see it approaches 0. Now, if I approach 0 from the right, that 2 approaches a value, but this time it's always 1 because it's a horizontal line, 1. So the limit from the right is equal to 1. So the limit from the left is 0, the limit from the right is 1. And since the limit from the left and right do not approach the same value, then the overall limit does not exist. Second thing that one-sided limits can be helpful for is in describing behavior of functions that have domain restrictions. So here we have the function g of x equals square root x minus 1. If we want to investigate the limit as x approaches 1 from the right of g of x, we can look graphically and see that the y value approaches 0 as x approaches 1. So we would say that the limit from the right is equal to 0 as x approaches 1. So graphs and tables aren't always reliable. This is why it's important to know the basics about some functions. We'll look at this example and analyze a table of values in this case to show why this might not always be the case. We want to take the limit as x approaches 0 of sine pi over x squared. We're going to use a table of values here. Notice that when you plug in 0, the function is undefined. So it makes sense that we would want to see what happens as x approaches 0. We plug in 1, you do get 0, 0.5, 0.1, 0.09, 0.08. Notice what's happening as we get closer and closer to 0. The y values are changing a lot. They're changing sign, the SIGN. They're changing in magnitude as well. And so if you look at the graph over here, the plotted values, they're just all over the place. And this is because this function fails to approach a specific value. If we look at the actual graph of the function, we'll see that it oscillates. In fact, it oscillates more and more the closer you get to 0. And this is basically because you're dividing by x squared. So as x approaches 0, this one, the limit does not exist because of oscillation. Now, if we take a look at the limit as x approaches 0 of 30 over 2 plus x squared, I'll graph the function here. And based on what the graph looks like initially, it looks like the limit is undefined because as you approach 0 from the left, it looks like the y values increase without bound. The same thing from the right. However, if I zoom out a little bit, you can see that the function actually approaches 15. So this is another thing with graphing functions is if you know a little bit about them, one thing here, the denominator is never going to be 0 for h of x, so the function will never be undefined. Also, if we adjust the viewing window, you can see more of the function and see that it in fact does have a limit, and the limit would be 15 as x approaches 0. And that's it for investigating limits using a graph. Hope that was helpful to you. Reach out if you have any questions. Take care.